All right. Today we're going to learn how to code Go. So this lecture is going to be kind of just all over the place. It's going to be a little bit of everything. You can read the slides if you ever just want to review what I talked about or reference it in the future. But I'm just going to be jumping around a bunch of things to learn so you can code Go. So let's get started. The first thing, don't use Git like a monkey. We have seen many people use Git like a monkey. You do not want to be a monkey. Do not use Git like a monkey. Let me teach you what it's like to be a monkey. So, for example, when you start working, you should do git pull at the beginning. If you don't do git pull and someone else from your team did some changes, you're gonna have merge conflicts. And merge conflicts make me sad. They also make Booga Booga sad. Before you commit, make sure to do git status to check everything that GitHub will push to push online. If you don't check its status, you might just push things that you don't want. We have seen people in the past push their credentials, environmental variables, or even node modules, and you're, in that case, uploading like megabytes and megabytes of data, which is going to make pulling really slow. So just before you push anything, make sure to do git status. An even better thing than git status is git diff. What git diff does is it tells you all the lines that you changed and everything that's going to be pushed. So for example, right here, I know that I added one line saying demo and a link to the demo. And I know that that's everything that's going to be pushed. So if you are overly cautious, do git diff. And another important thing is make sure that it works. If do not push broken code to GitHub, it makes everyone sad. And even worse, if you push broken code to GitHub, sometimes Heroku will automatically pull it and your website will crash. You will learn about deploying in the next lecture. But if you push broken code, you run the risk of your website just crashing. So at least make sure that when you run npm start, it actually runs. So this is a little bit less important, but make your commits make sense. What I mean by this is make sure that every single commit that you make is as small as possible. So it only focuses on one thing. So for example, here, I have one commit that just fixes the auth middleware that I put. And at the bottom, I have something that's a mega commit. And this is bad coding practice because you added a bunch of things in one commit. And if you just want to remove one of them, you're going to have to go back, see the lines in this commit that are relevant to a specific feature, and then push another one instead of just being able to roll back. To avoid having mega commits. And another thing, a couple commands that you should absolutely avoid. This one's kind of contested. Git add a period. Many of us use it, but you shouldn't. It is bad practice. What it does is that it adds everything in the current directory to Git. And if you have not run git status before, it will add basically everything. So what you can do to avoid this is set up something called a .git ignore file. And even if you do git add period, whatever file you list in .git ignore will not be pushed to GitHub. You can see the TypeScript skeleton for an example of a .git ignore file, or you can just Google it. They're pretty common. The next one is git push force. Whenever you see force in any GitHub command, be really, really careful. If you use force, I assume you know what you're doing. But most of the time, people don't know what they're doing when they're using force. What force does, it essentially tells GitHub that regardless of how bad what I'm doing is, do it, which is not a good relationship. So avoid this. Same thing with git reset hard. So you have used git reset hard many times in this class, in every single workshop, but that's because we have set up our repo in such a way that we don't care if you delete all the changes that you have made. So what git reset hard does is that it looks at every single change that you made since you pulled, and it just deletes it. So you have worked a lot of hours, and then you just do git reset hard. You just lost a bunch of work. And this is really sad. Don't do it. Git commit amend. It changes history, and you don't want to change history. It's kind of sketchy. Just make a new commit. And that's basically it for not using Git like a monkey. The next one is going to be about code formatting and style. So you have seen many of people from staff take code like this and then just automatically make it look nice. So the way that we do this is by using something called Prettier. I think Dson made a Piazza post like a week ago about how to make Prettier work. But what it essentially does is that every time that you hit save, it just makes it look nice. It's nice to have. There's only one downside to using Prettier, is that if you use Prettier and your friends or like your teammates don't use Prettier, then you run the risk of reformatting all their code. And you're going to have huge diffs. So just make sure that if you decide to use Prettier, everyone else who's going to touch your code also uses Prettier. Or else you run into like weird merge conflicts just because of formatting. Okay, so that's a little bit aside on just formatting. I think one of the most important ones is writing quality code. So writing quality code is kind of an oxymoron when you have a hackathon or a programming competition that lasts only 1 month. But try your best to write quality code that makes sense. So you're going to run into this scenario, either in this class or in future classes, where you have to make a choice between restructuring your code, renaming files, moving things to make one change. And this will take you, I don't know, 3 hours. Or you could just modify one function and then move parameters a bit, and then add the feature in only 30 minutes. Which one do you guys think is the better way of doing things? Yeah, number one is the best way to do things. So the reason that you want to do number one is because you want to avoid happy code. There are cases where you don't want to do number one, but I'll get to that towards the end of the class, towards the end of the lecture. But if you have a bunch of like hacky code that you keep writing just to add features, your code will eventually become a mess. It will be difficult to understand. Your teammates won't understand what it's doing. You won't understand what it's doing. The staff won't understand what it's doing, or maybe we will after a good hour or so. But happy code is generally just inefficient code that could be hard to follow, that breaks really easily, or just uses things in a way that they shouldn't have been done. For example, like using get requests in the wrong part inside a component in React. We see this quite a bit, and it leads to hacky code. So the way to like deal with hacky code is to just not have hacky code. And the way that you don't have hacky code is by designing well from the start. So what you want to do, I think there's a Piazza post pinned about this, is that you want to sit down and design how your app will work at the beginning before you like write any code or like even design how the UI will work. What you want to do is like first like make sure like you have wireframes, you have like an idea of what you're making. Afterwards, you want to like break it down into its component hierarchy in React. Then you want to talk about which data you're going to store, how you're going to store it, the schemas that you're going to need, stuff like that. And then you want to write the API endpoints that you'll need. So an API specification is a huge document. It could be a Markdown file. It could be a Google Doc, whatever you think is easier. That just tells people that are using your server or your front end what endpoints you have. So for example, we made a website called Portal that we use to grade students. And we have a huge document that tells everyone in staff, or like at least the people that are working the front end, what methods or what endpoints they can reach. So it tells you the name of the endpoint, what it specs as its body, and what types those parameters should have. The other reason that you want to avoid hacky code is because you're going to spend 80% of your time reading code. Only 20% of your time will be writing code. Whether it's reading documentation, whether it's reading your teammates' code, or even your own code, you're going to spend most of your time reading code. So you want to make sure that the code that you write is easy to understand. Because sometimes, even if it makes sense to you, if it's not easy to understand, your teammates that will try to modify it will not understand it or will take a lot of time to understand. So the natural question is, what is clean code? So there are classes like 6031 that are going to really instill in you the idea of clean code. And I will try my best to talk about the, I think that link is dead. I'll fix the link after my presentation. But yeah, so there are classes like 6031 that teach you like throughout the whole semester how to write quality code. And I can't possibly tell you every single detail about how to write quality code in the next half hour. But the first one is the dry principle. This one's pretty common. It means don't repeat yourself. If you're ever seeing huge chunks of code being repeated, or even small chunks of code being repeated, it probably means that you gotta abstract it away into a function, or restructure your code in such a way that you don't need to repeat yourself. This is a pretty common code smell to detect, because you can just see how often you repeat code. The next one is having meaningful names. So I'm going to give you guys a peek into how Buka Buka works. And even though there's a lot of implementation details that are abstracted away in this code snippet, it's somewhat easy to follow what the logic. So if we read through the function from top to bottom, this function is called setup state refresh. So this probably means that it's a way of refreshing all the data that we have at some point. Then inside there's a function called run every minute. And without even going into the implementation, I can tell you guys that it's a function that runs every minute. And inside there, I put a function that finds happiness from students, then emits a happiness level, and it throws an error. And it throws an error if you can't find happiness. So this code is pretty simple to understand. And this is kind of what you want to strive for. There are details right here that could be cleaner. For example, there's no way of knowing that run every minute takes in a function. But because I'm using TypeScript, I can tell that it uses a function as a parameter. If you use JavaScript or something, you want to add more documentation about this. But with TypeScript, you can just see what parameters it takes and what the type is, and it's pretty easy to understand what you should put in. So the main idea is to have meaningful names. Meaningful names are probably one of the most important skills as a software developer. If the names make sense, if you can easily name what a function is doing, it's a signal that the function is clean. If you struggle to find the correct name for a function, it's normally a sign that whatever you're trying to do is too complicated, and you should break it down into smaller functions. And that is the perfect segue for my next slide, functions. So functions should be small. They should only do one thing and take as few parameters as possible. So if you ever have a function that is doing a bunch of things, it's making a call to MongoDB, it's writing to Google Cloud, it's emitting a socket event. If you have a function that's doing a bunch of everything, it means that it's really hard to use it correctly, or at least it's really unclean. So you want to make sure that you break your functions down such that they do only one thing. And the reason that you can tell that it's not doing and a way to tell that it's not doing one thing, a pretty obvious one, is if you ever take Boolean parameters, so true or false parameters, it means that there's basically two functions or two things that you're function is doing, depending on a Boolean parameter. And this also means that you should break it down into two: a function that should run whenever that parameter was false, and a function that should run whenever the parameter was true. There's many coding books that teach you how to write clean functions, and there's a lot of debate online about what a clean function is. But the main idea is to have like very small amount of code inside a function. You have very few parameters. The optimal is 0, but it's very hard to get 0 parameters for everything. So you can use 1, 2, 3 is pushing it, but there are cases where you need to use 3. 4 is seldom the right thing to do. If you have 4 parameters, I feel your code might need a little bit of restructuring. But there's probably a case where you need 4. Okay, so stepping back from functions, another important thing about functions is that they work. It's very important. If your code doesn't work, then regardless of how clean it is, we're not going to use it. And the way to verify that it works is to test your code. In this class, we will not expect you to ever write tests. Testing is cumbersome, and testing takes a bunch of time to get right. Most likely, the best thing you could do without spending a lot of nights coding tests is to just load your site, work through all the UI things, make sure that everything renders correctly, and then do everything a user will be able to do, and just make sure that it works. So this is kind of just user testing. If you want to write unit testing, there are libraries like Mocha and libraries like Jest that will do this for you. And how they look, it's kind of like this. So I wrote tests for Buka Buka just because Buka Buka is over-engineered. And there's like 15 tests that run. And testing just makes me feel safe. So what testing does is it runs get requests or post requests to every single endpoint that my server has. And then I can say what kind of status code I was expecting or what kind of response I was expecting from the server. And it just runs it for me. Instead of having to run npm start and npm run hotloader, I can just run npm test, and it will test every single endpoint that I have. And they do fancier things. Like right now, it's telling me every single file or every single line that was rendering the test. And it tells me which lines I didn't test. So right here, I tested 82% of lines, which I think is pretty good, but it could always be improved. But yeah, you can talk to me about setting up tests. I feel it won't be too hard. If you come to office hours, I can help you set up testing. But then again, this is not needed. This is just me because I want to over-engineer things. For the competition, you just kind of want to walk through your code, open your website, and make sure that it works. Oh, another thing on this vein is that when writing endpoints in your server, don't expect the front end to be nice to you. We will look at your front end and back end code and see if there's ways to break your code. So for example, let's say you have an endpoint that changes the name of a user, and it takes the ID of the user and then the name that they should have. If you're expecting the front end to pass the right ID, someone that has some malicious intent or just wants to mess with your site can just put the ID of another user and change their info. So you want to make sure that the user that's making the request is the same user that you're modifying. This is kind of a very simple one. But in general, don't expect the front end to be nice. Don't expect your function to be called with parameters that you just expect to be in the right form. Also, a fun fact, you can make tests run automatically in GitHub. It's called continuous integration. And I wrote continuous integration for Buka Buka. So whenever I made a push or a commit, it ran a bunch of tests and it ate up all our the GitHub hours or whatever it is. So we had to shut it down. It was really sad. Okay, so stepping down from testing, let's talk about consequences of janky code, aside from not being able to understand what's going on. So I alluded to something called code smell. So code smell is the ability to understand, to like detect code that is Yankee. And this is an ability that you kind of gain over the years or just by coding a lot. But to start off, one of the things that you should be looking out for is copy and pasted code. Do not copy and paste code from Stack Overflow. It will most likely not work, or even if it works, you won't understand how it works. It's a bad idea. Again, functions that are too long, lines of code that are way too long. Dead code. So dead code is code that just doesn't run, that you never call, or files that you don't even touch. To just avoid, if you ever see any of these in your code, uh, it means that there's something sketchy happening in your code. Okay, so assuming that like for some reason there's a bunch of hacky code, you wrote this in at 3 a.m. the day before milestone was due, and to be honest, that was probably the best choice. I'd like you guys to sleep. If it's 3 a.m. and you guys can write hacky code, just as long as you fix it at some point. The reason that you want to fix it at some point is because hacky code creates something called debt. So for example, let's say you start up the project, you download the skeleton, and because our skeleton code is perfect, you have zero technical debt. And then you start adding features. And the feature is a beautiful feature. It works correctly. It has even no parameters. It has short functions. It's a beautiful feature. But then you want to change it a little bit. So you add a quick hack to add a new feature on top of that feature. And you have a little bit more technical debt. And then further on, you add another feature. And this is, again, a beautiful feature. It's coded correctly. You go to to office hours, and we tell you that it's a beautiful function. But then you write another hack on top of it. But now to make sure that feature one works with feature two, you got to add an extra hack in the middle. And then as you're adding more and more features, everything is glued together through hacks. And your technical debt just keeps going up and up and up. And when you get to 100% technical debt, it means that you cannot make any more features because adding any more features is really complicated because you gotta like add more hacks and more hacks. And it just keeps breaking. So when you reach 100% debt, you gotta start paying it off and paying it off until you have um, a somewhat workable software. And as a fun fact, the amount of time that you're gonna be spending paying the debt is much more than the time that you would have taken to just not need hacks at all at the beginning. So this is the reason that you'll want to spend 3 hours making quality code instead of just implementing it quicker and only takes half an hour. So after you pay your enough debt, you're still going to have hacks, or you can spend a bunch of time getting rid of the hacks. But as a like main idea is that technical debt accrues interest just because the complexity of your web app gets exponentially more complex with the number of apps that you have. So just write good code from the start. And a question that you're probably going to have is it worth it? And is it worth it is kind of a hard question to answer for all cases. My personal opinion is that it's all worth it. However, I can see where there are cases where it's not worth it. So again, it's 4 a.m., the day before milestone 2 is due. Your code is not running. You can either have good coding practices and spend another 3 hours trying to fix it, or you can just spend half an hour, put a hack, and make the website work. I would say that in this case, it's much easier to just add a hack, make it work before the milestone is finished, and then worry about it the next day. It's kind of like a balance between like deadlines, sleep, stuff like that. If you're ever losing sleep over code, don't. Please don't. I did this a lot as a freshman for WebLab. Don't do it. It's fine if you have a hack. Again, this class is basically a long hackathon, especially towards the last 2 weeks. You're gonna like start writing hacky code because you need to plug code, and I understand that. So just make sure that you keep your depth in check. Okay, so now moving on from the whole like hacky code, clean code topic, let's talk about comments. So comments are normally helpful. However, they sometimes can be too helpful. So let's say you wrote code in 2 different versions. Which one would you guys prefer, the left or the right? Yeah, good point, Daniel. The right one is much more readable. The reason it is that there's such a thing, such as over-commenting. Over-commenting is normally like writing comments about things that are obvious. So for example, if we read the left, this is a route. This route is a GET request for the user. I can tell that it's GET request because of the word GET. And I can tell it's for user because it has the word user. And like same idea with all the rest of the comments. Like do nothing afterwards, I can see that you have nothing or that you're doing nothing. You don't have to write a comment about doing nothing. And again, you're going to be spending 80% of your time reading code. And having a bunch of comments in your code is going to make it harder to find the right line of code that you want to read. So another thing about over-commenting is that if you got to write huge paragraphs about how your code works, it means that your code is also unclean. The best code doesn't need comments. And there's people online that will like disagree with us. But if you write clean code, the amount of comments that you will need are minimal. There are cases where it's hard. For example, right here, this probably needs comments to figure out what's going on, right? I have no idea what like headers are or what headers the headers variable even has. I don't have, no, I have no idea what operation 3 is or operation 1, 2. So even though the code has like minimal code, it doesn't really, it's really hard to read. So some people are going to add comments to this and say like operation 1 gets images from Google Cloud, operation 2 pulls the user schema from Mongo, operation 3 adds everything to the database. I don't know. The better thing to do here will be to just rename the variables. This is an example of bad naming. Instead of adding comments, make the names more obvious. There are cases where no matter how good the name is, you still need a comment. For example, this is normally when you are like you're using a third-party library, and you gotta link to the docs to make sure what parameters you can use. This is a good use of comments. Yep. So for example, this is the code we've written, the code that we saw before, but with actual good naming. And this doesn't need comments. And I know exactly what each function is doing. Cool. So after talking about like writing code, now I'll talk about debugging. Debugging is something you're gonna do a lot. And Kai told you guys how to like debug a little bit a couple days ago. But in general, you want to use the Chrome developer tools or the Firefox developer tools and the terminal console logs to figure out bugs. So for example, let's say we have this bug that we are not rendering the profile data, even though we're logged in and even though we went to the right URL. So what you should do is open the terminal window and open the console logs inside Chrome and figure out what went wrong. So right here, the browser console has an error with the GET request. There's no error in terminal, and there's no error with Webpack. So this kind of tells us that the error was in the GET request, and we couldn't get the user. And it tells us what GET request we were trying to do. So the next step to do is to go into the server that checks for this endpoint, and then just print out the data that you're getting from the front end. So the relevant thing here seems to be the query that you're putting and maybe the user ID. So if we print this out, we're going to see that even though user ID is there, the field that we're looking for is undefined. And we're getting nothing back from Mongo. And right here, the bug is that user ID is spelled differently in the query, and the field that we're trying to get is all lowercase. Fun fact: TypeScript will not let you do this, but vanilla JavaScript lets you do whatever you want to do. So this is a common source of bug, just misspelling parameters. Again, if you wrote API documentation, you could probably figure out what's going wrong. So the fix to this will be to rename it and would that go work? Another thing to check, if you ever want to figure out what part of your code gets stuck, or even if some part of the code is running, use console logs. There are more powerful things like debuggers and React developer tools and a bunch of things.
Hello.
I have always stick.
Oh God.
Okay. I have always stick to console loggers. It's just more natural for me. So just print out variables, print out just random words, figure out where your code is getting stuck. And the next topic is to avoid writing a bunch of code at once. So imagine you write 500 lines of code, you open your front end, and it's just blank. It just doesn't even show up. At this point, it's really hard to figure out what exactly went wrong, mostly because the more lines of code that you write is the more amount of time that you're going to spend debugging. So instead of writing 500 lines of code at once and then trying it out, what you want to do is make small changes, then go to your front end, check that change worked, and then move on to the next change. You want to make sure that every time that you write an endpoint or every time that you add a UI component, you go to your front end and make sure that it works correctly. And for example, NodeMon makes this really easy because it will automatically recompile your code. And another thing for debugging is make your friends or your teammates look at your code. Even though it could work, there are a lot of bugs that could go unnoticed, and they may show up the moment that your web app is being deployed or right near the deadline. So what you want to do is make sure that everyone, or at least someone else in your team, understands how your code works. So if you want to be really fancy about this, you can make everything into branches and then just submit PRs and make other people review the PRs and be extra. And this is what I did for 6170. But you don't need to do branches. You don't need to do pull requests and stuff like that. But as long as your teammates know how your code works, they look at your code and make sure you're writing quality code, it's going to decrease the chances that you have bugs. The more people that you look at your code, the better it is. So in summary, git responsibly, limit the amount of hacky code that you write code that doesn't need a lot of comments, have a tight debug loop, and don't push more features until you have fixed the bugs that are currently in your app. And yeah.